This is a softmax function, so we have some numbers. These are usually going to happen in output layer of neural network, but let's say we have array of numbers. This function that I will explain, and we get array of probabilities, and they all add up to 1. And also higher numbers are stronger, have stronger probabilities, and they are strengthened a lot in reference to the other numbers. So let's say we are calculating this 0.02. We will have this number 1.3, put e to the power of 1.3, and this is the value of e, its approximate value. And in the denominator, we will put e to each of these numbers. So e to this number, e to this number, and we will sum up all of them. So plus e to this number plus e to this number. So that's gonna help us normalize these scores. So this number, e to this number, divided by, sum of e to all of these numbers. There are multiple reasons why we are using e to the number and not just the number. First reason is this would always be positive number. So we don't want the probabilities to be negative. So if we get negative numbers here, we want to somehow always transform them to positive numbers. And putting e to this number will do it. Also, this will strengthen and amplify big numbers to be even bigger relative to the other numbers. Now you can control this. You can make this weaker or stronger to make these numbers weaker or strong, or the difference between them smaller or bigger. In LLMs, we can control that with temperature and other softmax scale like parameters. And the reason we divide with sum is to normalize them, so they will all add up to 1. So we can use this as probability distribution. So this is 2%, 90%, 5%, 1%, 2%. And we can later assign, for example, this is next token cat, next token is dog. Probability that the next token is fish is 5%, probability next token is tree is 1%, etc. Let's look at how we implement this in Python. So import numpy, and let's define this softmax function. It's gonna be very simple. So we will subtract maximum number. Here in this array, we will subtract 5.1 from every number, just so we get more stable numbers. And now this e will not grow too much. So if we subtract the maximum number from each, then the difference will not be this big. It will be smaller. So that's what you can do if you want, but you don't need to. So this will just stabilize the numbers. And so we calculate exp of x, e to the x, and x is zi in this. So x is going to be a whole tensor. So when we do this, we will put e to each of these numbers in this tensor. And so we will convert this tensor into e to 2, e to 1, e to 0.1, etc. This is what it would look like. So this is the resulting vector that we would get. 7.3, so that's e squared. This is e to 1, etc. Then we will sum up all of these exponentials across first dimension. So first dimension is this dimension, it's just this one. So this is innermost dimension. So we will sum up e to this plus e to this plus e to this. And that will be one number, and then we will have another number next to that. It's gonna be across this dimension. So this will give us two numbers. And when we do softmax output, we will have these like, for example, we're gonna have these numbers each divided by the sum of those numbers. And then here, these numbers each divided by the sum of those numbers. So before I show you the output, let me comment out this line that subtracts maximum value from each, because it's confusing even me. Okay, so this is what we got. Exp of x is exactly what we expect it to be. And then sum across each of these is going to be 11, and here 17. It seems right. And input vector, this is the original vector, and these are the probabilities in the end. So they are all supposed to add up to 1, which I think they are. And I will show you PyTorch implementation. So we will import PyTorch functional. We will create a new tensor, PyTorch tensor, that's same as this NumPy vector, but we need to have PyTorch tensor for this to work with PyTorch function softmax. And we will just say f.softmax input tensor across last dimension, innermost dimension. And we will get the exact same thing here, exact same thing. So you can also convert a NumPy array into PyTorch tensor without manually creating it again like this. So our input vector, that's NumPy array, I can say torch.from NumPy and put in NumPy array to get PyTorch tensor. I can also create a copy. This is conversion, this is copying. So copy torch.tensor input vector. Check out my other videos like coding DeepSeek from scratch. See you next time.